So I have the legged layer of my robot finished, and now I want to convert this, the main body of the robot, so that it will fit onto the legged version. I think that if I just take the tracks off this, I should be able to just take this layer and stick it on the legged version with minimal changes. There's a big space in the middle here where these batteries can go. So the batteries can sit in just as they are, but I could also switch the batteries, turn it the other way around, which will stop the batteries from falling out. Right, let's get on with this. Actually, let me take that off. So I'm left with just the board, batteries. Now let's just check the fit. So batteries here, power supply is there. That's just perfect. Just out of curiosity, I thought I might just enable the board here and just see. I've hooked in the motors. Nothing here is connected. Everything is loose. But I'm just wondering, would I be able to make it move? I can't video it because it's on my controls are on that thing there. So I'll just do that. Oh no! I put it together, and as you've just seen, it broke. That's the third time the legs have broken in a similar way, and it's time for a redesign of that. I have a number of actual, like, I printed out the new base, stuck it on, and there's a number of problems with it, so I've got some redesigning to do. So the legs keep breaking because of the way that 3D printing with FDM works. The FDM is a fused deposition something, modeling maybe, manufacture. The way that works is that when you're 3D printing something, it's basically printing one layer at a time. So you print one layer, then another, then another, then another. Now that has a problem in that the layers themselves can separate. And that's exactly what's been happening in this. So on the thin parts, where's my camera? There. Right. On the thin parts of the model, as it's printing upwards, the thin parts end up being very, very weak. So the solution that I'm going to work on this time is that I'm not going to print the thin middle part. Instead, what I'm going to do is I'll print the cog, but the cog is going to have a rectangular slot in the middle, and then I'll print out a rectangular piece, flat, so it's very, very strong. Like it won't be weak in the Z direction because it'll hardly have any Z direction. It'll just be flat rectangle, and that should be strong enough then to solve the issues that I have. Now, other problems. Okay, so this is the model. Now, for what feels like the 10th or 15th time in a week, I have to take the legs off again to change the gears. I have to take everything off. So what I'm going to do is redesign the base so that it's not the outside that's part of the base, but the inside. So I'll just be able to take the legs completely off outwards, and that should make it much easier to change the cogs. I will also at the same time try and make the cogs a little bit more freewheeling. At the moment they're very stiff, and there was something else. Yes, the large battery box underneath there, I'm not even sure if it's needed anymore. Now the reason that I had a battery box here and the batteries here is because I've had problems in the past trying to power a Pi and motors at the same time. But these batteries here, they're the 20 amp 3.7 volts batteries. So 20 amp is a lot. I mean, the Raspberry Pi takes up to 3 to 4 at a high load. It'll take 3 to 4 amps. The motors themselves, I'm pretty sure they won't go anywhere near 20 amps. So there shouldn't be any problem. Now the problems that I've had in the past were mostly because I was using breadboards. and a breadboard connection, a breadboard electronic connection is not as strong as if you were to just solder things together. So since then I've been soldering things together instead of using breadboards. So what I'm going to do is redesign this so that it doesn't need that large battery box, 12 volt battery box, which is a good thing as well because it reduces the weight. So that would eventually allow me to make it thinner, which I'm not going to do right now, but you know, it would eventually let me do it thinner and lighter and smaller. So for now, I'm just going to redesign the base and start it printing, and then we'll fix the legs. I slept on this overnight and thought about how I want to fix this problem where the leg keeps breaking, and I realized that there's a lot of problems that I actually want to fix. So I'm going to rebuild the whole thing again. But this time it's going to be in 3 definite parts. There will be the battery layer, which will be a flat line here and the batteries below. But I'm not going to use the 1.2 volt batteries here. I'm only going to use these 2 batteries here. I think I might be able to power the Pi and the motors at the same time. I think I know the power problems that have stopped me from doing that before. So there'll be 1 layer for battery, then motor will, the vehicle layers would actually be attachable bits that just attach onto the side of the battery layer. And then I will have a separate box at the top, a separate rectangle at the top, or platform, which holds the computer layer. So I could even use this, basically this computer layer here, computer and sensors and anything else that we eventually stick onto the top. Okay, so it'll eventually look again like this, but I think it'll be a bit more compact. Now, another thing as well is that I started off having 3 legs in this this fashion here, so they're kind of facing forwards. And then I added on an extra one at the end. So I had 3 legs in one direction and I added an extra one at the end. I like this, so I'm going to actually replace these 2 with one of these. And the bonus here is that you only need 1 driver for a drive wheel for the 2 legs here, whereas I've got another drive wheel and another drive wheel. So that cuts down on the amount of movement that has to go on. I might still end up using 5 cogs, but I don't need as much. Well, maybe I'll need as much force, I don't know. But it's less things to go wrong. Less things to go wrong is always good. I'll put a hole on the top so I can just reach down into it and pull the batteries out whenever I need to, which I really shouldn't need to because I also want to build a charging circuit into it, which I can't do yet because I don't have the components. Problem with charging is that you can charge 1 battery on its own, simple enough. There are lots of components. There's one called, I think it's called a TP4046, something like that. And do I have any here? Yes, I actually do. There's one there. So that's I think that's what it's called, a TP4046. 4056. TP4056. That will charge 1 battery. But you can't charge 2 batteries in series because this is in series. These 2 batteries are in series because the power, you've got negative here, positive here, then the positive is connected by wire to here. So positive, negative, and then you've got positive again. So these are in series, not parallel. So if I was to charge 1 of these, then the charger basically has a 0 volt at one end and 5 volt at the other. And then charge at the other side, 0 here, 5 here. But the thing is, you got 5 and 0, you're shorting this out. So you can't charge these 2 straightforward, but there is a way of doing it by building a kind of floating voltage. But I don't have the components yet for that, so I'll have to order them in. Okay, let's get back to this. Okay, and that's a robot. That's a robot. So I'm going to print all that out and see if it all works first time. So it's been, today's Tuesday, it's been 4 days since I did the basic design. and I'm still printing and still printing out the pieces and redesigning as I go, as I discover issues. So let's see, what have I discovered so far? Right, so far, let's see, the places where the wires for the motors come through, it's fine there. On this side, I forgot that I put that switch there, so the wires are going to come right through the switch, so I moved them. Pi, I had a Raspberry Pi here for this, and as I was just testing out the positioning of it, I accidentally shorted it out, because for some stupid reason I've left the batteries in, and you know, even right now I still have the batteries in there. But I discovered this is the Onion Omega2 Plus, a very small computer, runs on 3.3 volts instead of 5. It's fantastic. I turned it on and within 3 or 4 minutes I had it up and running and connected into it through Wi-Fi, and it was connected, I was connected to it through its own AP, and it was connected through my own Wi-Fi AP. So I was completely online with it. It's fantastic. No need to download an operating system separate and install it. It's got an SD card slot on it, but I'm not going to need that. So I'm going to use this instead of the Raspberry Pi. So I've just soldered on the wires where they need to be. It's perfect. I like it. Right, next problem. A number of little problems in here. Forget about them, it's fine, I've got them fixed anyway. Right, biggest 2 problems. Let's see. Number 1 is these things here, which the legs are going to mount on, they break off too easy. So I've decided to use screws in those cases. So I just drill a hole straight down the middle and then put screws in. But the biggest problem I have at the moment is the cogs. Because cogs are very complex, it's very hard to get the right angle to print at. So the problem has to do with printing. It's very hard to see in this light. Let me just see if I can get that closer. It's very hard to see, but that's not, it's kind of squished near one end. That's because it's printed kind of upside down. Let's see, here's one here. Right, you can see how it's not completely vertical on one side. That side there, so that prints upwards like that, and as it prints, the first few layers are actually printing almost in thin air. I mean, they're not actually in thin air; they're on support, but it acts as if it's almost in thin air, and you don't get a straight. You don't get it to be nicely detailed. So what that means for us is that the what would you call them, triangle things, are not equal on both sides, and you really want them equal on both sides when they're connecting to each other, when they're supposed to link into each other. So what I've done is I've went back to them and broke them into 2 pieces. So they're actually printing in this was actually printed in 2 pieces, a top half and a bottom half, which are identical basically. One is a mirror of the other, but they're basically identical. And then I glue them together. Stick them together with these little vice things that I printed out a while ago for something else, and that keeps them nice and that sticks them nicely. So we end up with it's almost a perfect print. It's got a really nice sharp top. All of the angles are nice and sharp. It's really good. So I expect that's going to, like, that really fits very nicely. I expect that's going to work out a lot better than what I had before. All this stuff here, very hard to turn. I had the motor on for a while just to see, and it would just freeze at a certain point because it's just so badly printed. I mean, it's not terrible, but it's bad. Okay, so right now I'm just redesigning the middle gear to cut that in half and reprint it, and then I can finish off putting everything together and see yet again to see if it works. Alright, back to 6 legs. Let's turn it on. It's Thursday morning, 6 days after I started the redesign of the bot, and I think it's at the stage where I can start the programming. So just a number of changes have happened while building it. most obvious is that originally I planned having 8 legs, so 4 here, 4 the other side, for stability purposes, but it turns out this is fine. If I put a leg here, there was going to be, you can see these two are opposing each other, they're symmetrical. I was going to have 2 symmetrical here as well, but the 2 middle ones were overlapping, and I just didn't want to reprint and redesign so it wasn't overlapping, so this is fine. The point of having them in opposing directions was these outer ones here. I want to have a stable base. You can see the distance between here. This stable base kind of stays constant as the thing runs, so it's like little to the left, little to the right, but it's always around there, which is just underneath the weight of the robot itself. That's what I want, and that's what we have at the moment. The middle leg is needed for the running, but it's not crucial for the stability of it forward and back. So I have that on both sides, obviously. Most obvious middle change is that I was using a Raspberry Pi, but I managed to short out the Raspberry Pi while testing. So here we have this is an Omega2 Plus, which is a tiny little computer. Runs on 3.3 volts, so all I had to do was really tune that buck converter down to 3.3 volts, and I had this up and running in a few minutes. So I've hacked this together so I can turn it on, but that's not the way it's going to be. Like that's just me hacking things together. I'll just rewire it so that I can hook the motors into the motor controller, which then connect into the computer itself via these wires. So the next stage is to rewrite the program that I wrote for the original bot. So instead of running on Bluetooth, it's going to go through Wi-Fi to a website which will control this and any other robots that register on it. So the idea is that I might be able to have 2 or 3 of these going around my garden, and each of them running under instructions from the same website. Right, so next stage, reprogramming this. Okay. Oh, there's yeah, so I had to make a lot of changes as well to various bits and pieces as I built. And just to explain how this all works, I've got the middle, this is the battery / computer layer. We've got this top layer that goes right across the top, holds everything in place. So that's a single rectangle. It's a square. It is a rectangle, yeah. And everything else basically hangs off it. So I've got the middle layer, which is screwed onto it. We have this, which is the motor layer. So I've got that and that. They're both motor layers. You look inside, you can see the yellow of the motor. You can look underneath, you can see the metal parts of the motor there. And they slot into place, and then they screw. And then finally we have the actual vehicular part. So these a gear section here on the other side, and the legs connect onto the gears. Now, handy thing here is that I could replace the legs very easily with tracks if I so choose. Not going to need to do that yet, I think, but it's still another option. So that means that I can change this back to a tracked vehicle if I want, without changing the printing of anything else. The design that I did in FreeCAD has been adjusted and changed a few times as I went, and even hacked literally. So I had to cut off a bit at the edge here because I got the size wrong. I've had to drill into bits and pieces because it turns out I'd overestimated the strength of the plastic in the first place. But overall, I'm pretty happy. I'm pretty happy with this design. I think it's going to work out well, and I don't think I'll have to redesign. I will, but I don't think I'll have to for the next short while anyway. So. So this phase of development is done. We have a working robot. It moves. I can program it to move in whatever way. I can't control it yet on the fly, but that's for the next stage. Now, while building, every time I build anything, I always think of things to change and fix after I've done it, and this is no exception. So in this case, it's pretty obvious. If I put this down on the table here, you can see it rocks. Now, what I want ideally is that it's completely stable at all times. That as it walks, it's completely flat. Because otherwise, if I attach a camera to this, it's going to be walking along like that and juddering, and the camera will not be, well, the picture won't be easy to read. And this is only a small computer, so that's going to find it very hard to see things as well. So I need to make this a lot more stable, but that's for the next video. So what did I learn in this? Well, first off, I got the dimensions wrong on a few things. I had to saw the edges off this. I learned that I can't have the 8 legs along here as I planned, because these are 2, and then, you know, if I have one here, then the other one is going to overlap with this. I mean, I could do some strange things to make it not overlap, but I don't want to go to a lot of effort to do that. For some reason it turns on at different angles, and I'm not sure yet why. Not going to worry about it too much. Let's see, other than that, I'm actually pretty happy with this. I mean, it's kind of modular. So you've got this this battery section, you've got the motor section, and you have the transport type section as well. So like, I could swap these for tracks without changing the rest. I could turn it into a hovercraft or a quadcopter without changing too much. Yeah, without changing pretty much anything. I mean, the only things that would change really are the outside. Everything else would be totally fine. So I'm happy with this. Yep, I'm happy with this, and I'm gonna build another one.